In this video, I will demo iHELP, or the Intelligent Holistic Emergency Logistics Platform. iHELP is a cloud-based system for generating optimized logistical plans in response to disasters or crises. The interface is divided into steps to implement a disaster scenario by entering first permanent data that you don't have to input every time, scenario data that's specific to the scenario at hand. You run the simulation and the optimization engine on the cloud, and then you can visualize the output that can be in the form of reports and maps. In this hypothetical scenario, the highlighted area represents a disaster area, and the corners around the polygon represent cities or countries that will help support the response to the disaster. To implement such a scenario, we need to input the data. Starting with the zones, we define the area where the disaster has taken place and the support areas that will support the response to the disaster. I can add a zone as you see in the screen, and I select its location by using an interactive map that will give me the exact lat and long. Then I can input the organizations involved in the response plan. In this particular scenario, we entered the organizations such as the WFP, the Red Cross, and NATO. Then I need to input the infrastructure such as seaports, airports, rail ports, and so on. As an example, if I click on airport, I can define the airports that can be used in the response plan. If I add an airport, I would input the name, the zone that has been predefined earlier, the location also through an interactive map, and I can put the category of the airport. Different types of airports, they have different categories. I can put the capacity, for example, the number of runways available to support the disaster, and I can put their availability. This would be in a date and time format. Any other special requirements can be input here. Then I need to input information about the transporters, including the types and the transporter fleet that is available for this specific disaster. If I click on the transporter types, I need to input its name, the mode of transportation, whether it's air, sea, road, or rail, the capacity in terms of volume and weight, the range that it can travel, and the speed, the average speed, and transportability. The transportability field is defining the items that can or cannot be loaded on that particular type of transporter. Then in the transporter field, I need to define the specific transporters from those types that are available for this particular scenario. So I can select from the predefined types, I can give it a name, and I can give it a quantity. I can define the owning organization and define whether it is it can be shared or not, and any special requirements. And I have to put the location, the zone at which the transporter is available, and its exact location on the interactive map. Next, I need to define the item types, such as food, water, medicine, and so on, that are available in the system. Typically, I would have a whole bunch of item types that are available in the system, and I don't have to input them every time, but I need to define those that are available in this particular scenario. So if I click on add a new item, then I will define the amount of supply that's available from that item type, such as food or water. I give it a name, I select the type of the item I want to transport, the organization that has that item, and the location, as well as the quantity. I need now to define what is required, or the demand, in the disaster location. I have defined here several requests. If I have another request for need, such as food, for example, I can give it a name of my choice. I can select the location where it needs to go to, and then I can define the need type. The need type is the predefined types that I defined earlier in the item types, and I can define the quantity that's required, and we have a field for priority. And finally, we have a trust index that is meant for input from the social media where we are not exactly sure how much we can trust the information coming from social media, which we will talk about a bit later in the demo. In iHELP, we can also define disruption points to the transportation plan due to weather or to something else. And we can define certain thresholds for weather conditions that will define a disruption for us and the type of conditions that we want to disrupt the transportation plan and either stop it or find another route to the plan. And if in case we want to have a disruption for a certain road, for whatever reason, we can just simply define the disruption point, its location, when we expect it to start and when to end, and the reason for that disruption and what mode of transportation is affected. An important module in iHELP is the service management module, which includes the service needs at the disaster location and the services and resources required to fulfill these needs. In the service needs, for example, if we have a need for food distribution and the location is defined based on the zones that have been already predefined, their location, the amount of food need to be distributed, and the start time of distributing the food and the expiration time, which is the time after which the service is no longer needed. Under services, we define the methods and the resources required to fulfill the need. So for example, in case of food distribution, we can distribute food using different methods. We can distribute food with volunteers or with first responders as an example. We define the service type, which is food distribution, the demand to fulfill using that method, and the type and amount of resources required to meet that demand or part of the demand. The duration that is required to distribute the food, as well as the preference for that method, where lower numbers meaning higher preference for that method. And we can define if that service can be disrupted or preempted and continued later or not. An important input to iHELP is social media data. We built social media simulator that resembles the most common social media platforms such as Twitter and Facebook, where the user can input their information and they can tweet or post something about a disaster. In this case, the tweet will be classified as a storm. They may not always tweet something relevant or something true, but our AI modules would be able to classify those tweets that are related to a certain disaster, and the user can input their tweets in any language of their choice, which will be translated and classified using Google APIs. The user can also select an image that's taken of a disaster and upload it to the system, and the system will also be able to do image recognition to classify the image into a specific disaster. The images may be authentic or they may be downloaded from the internet. If they are downloaded from the internet, we will be able to detect that and they will be given lower score of confidence or trust. All tweets will be given a score to give the analyst or the decision maker an idea how reliable these tweets are, and they will be aggregated per location as we will see in the output. After we click on Run Simulation, we can view a visualization of the simulation. If we look at this map, you will see the input that we entered into iHELP on the map. You can see the infrastructure and you can see the different components. So for instance, here we have an airport, here we have a rail station, and we also have seaports if they were part of the scenario, and so on. In a little bit, you start seeing the movements of the transporters. So for instance, here is an aircraft carrying some items from an origin to a destination. For each transporter, you will see the same kind of information in this info window, and you can click on it and view it. In fact, we can also look at the menu on the side, and we can click to see what social media has been saying about this disaster, and currently through our simulator. but we can easily turn it into the real Twitter to capture tweets. Right now, we have some tweets that we entered into exercises that have been classified through our AI technology. So for instance, this tweet has been given a score and classified into one of the disaster types. Same thing for this tweet, where scores of between 0 and 1, a 0.7 would be of high level of trust to some degree. If the score was very low, it means that the tweet is not relevant or it is not reliable. If I turn off all of these tweets, I can check only one type of information, let's say the need for food. So in this case, I can click on each tweet. I can view the information, the actual tweet, and see how much of trust score it is and how much I can trust it. All the tweets will be aggregated and they will be given an aggregate score that will give me per area how much there is a need for food or need for water or something else, depending on the input from the social media. If I go back and select all of these, and then let's look at the weather module. If I click on the weather, it will show me the weather in the disaster area as well as the other areas, support areas or other cities. So for instance, in this case, I click, it will give me the actual forecast at that point in time. I can also view the forecast for the coming 5 days broken down by 3-hour windows. And that will give the user or the analyst an idea how the weather would look like and whether to anticipate any disruption to the logistical plan. To evaluate the logistical plan, iHELP produces different types of charts and reports. In this chart, iHELP captures the activities of each transporter as a Gantt chart to show the time spent in each state, their departure and destination locations, and the items they are carrying. In this pie chart, the time spent per state, per transporter can be visualized as a percentage, and we can also compare these percentages across the different types of transporters. Transporters can be selected and the graph will dynamically be updated to be able to visualize all of them if we need to. Inventories of items such as food and water are very important in cases like this. This graph tracks the amount of inventory at the supply and the destination locations, and you can hover over the graph to see the amount of food that has been delivered, for example. You can always filter by location to see the inventories at hand. Service charts are also produced to show the rates at which services have been fulfilled. For example, in case of food, this is the starting time for food distribution that is required or desired, but this is the actual starting time. And then we can see here the point at which 75% of the food distribution has been completed, and this is the time at which 100% food distribution has been completed. You can also filter by location to see how the services are being fulfilled. The resource usage chart, it shows you how reusable resources are used over time, and you can track each resource by color to know what's happening with the resources and how much of it is being used. In the service Gantt chart, it's similar chart like the transporter Gantt chart. It captures the activity of other reusable resources, and it shows you the distribution method that's being used and the amount of that resource that's being used. You can always focus on one type of activity, such as food distribution in this case, and you can see how the reusable resources are being used and at what location. You can always switch back and forth between locations. In summary, iHELP is a simulation and optimization framework that was implemented using open source technologies to optimize logistical plans and distribution of relief in case of disasters. Social media is an input to iHELP, and it currently uses AI and machine learning to classify tweets and posts from social media into different types of disasters and score them for trust. We would like to extend the social media work to focus on acute hunger and food shortages in disasters. We will augment the system with more sophisticated models to extract information from social media about people's food needs in case of disasters or in areas of conflict.